I thought I'd just wrote something down on the basis of yesterday. So, my name's Chris Hanson. I work at Statistics New Zealand. I work in the methodology area there. And just sort of responding to a comment yesterday about the use of open source tools in big organisations, I think it probably is surprising to a lot of people in conferences like this that a statistical agency, this is not rare, most statistical agencies don't really use tools like R very much. They tend to use things like SAS and other proprietary products. I just wanted to point out that there are pretty good reasons for this. It's not as easy as it might seem outside of academia and sort of private use. Until pretty recently, R really wasn't good enough for our use in terms of handling large data sets and things like that. I mean, these are things that SAS, while it's proprietary, can handle pretty easily. And we have very large existing code bases, and these things can't be ported overnight. So, so the ability for us to get R in pretty heavy use at Stats New Zealand has been quite an interesting journey. And so I guess what I'm largely talking about here today is, the things about that process that I thought, the things we did that contributed to the rapid sort of uptake and adoption of R. So I've got a lot of slides. I'm probably not going to get through them. I've listed them in sort of prioritised order, so I'll just stop, and hopefully I've covered off the most important things. They're also kind of wordy. They were sort of designed for something else that needed to be readable after the presentation, but we'll see how we go. I'll just skip that. So the background is, so we've been using R, somewhat informally for quite a long time, actually more than 10 years now, probably closer to 15, 20 years. We used S Plus a little bit. But subject to a myriad of practical issues as I described. So until very recently, we still actually only have 32-bit desktops. They're far too resource poor. We've got some pretty arcane, or have had in the past, some pretty arcane security policies. Makes things like, we couldn't even download packages from CRAN, right? It was seen as an unsafe thing to do. So we would actually commonly just download the entire CRAN repository to a local folder and then install packages manually one by one, right? You had to resolve all your own dependencies. Horrible. We had irregular and frequent updates, so we just weren't supported by IT. There are no authoring tools, so writing in C++ and things like that were pretty hard. And really poor support for third-party tools, particularly on Windows. So if you had a package that needs some third-party application, like a front end that even needed GTK or something, that's near impossible, right? That would have to be bundled as a separate application and all sorts of security issues. So in 2014, we put together a business case to make R a first-class citizen. So originally, we were just going to go down the road of trying to get the Windows desktop version just sort of better supported. But there's a sort of general direction in government, which is to centralise all sort of things related to compute. So we actually, in the end, settled on a server-based model. And what was really interesting about that was, hopefully I'll get to it, we decided to do it in-house, which was quite surprising, because there's also a big push in government, or particularly New Zealand government, to outsource, sort of server management and that sort of thing. So here's just a sort of picture of the old desktop environment. And this is our new environment. So we've got 2 production servers at the moment, each one running, at this point, Debian Linux. That's not terribly important. So they have RStudio Server Pro installed on them. Each has 100 gig of RAM, 36 cores. We have a test server, which is pretty low end. That's just for sort of staging deployment or upgrades. And we also have a server available in our data lab now. So we have a sort of a secure environment where researchers can log into either remotely or come into like a sort of little secure room and run code. So they typically use SAS or Stata or something like that now, but they can now use R on one of these RStudio Server Pro boxes. It has similar specs to our production servers, 100 gig of RAM. So it's been really successful. The server, so here's a screenshot, by the way. So this is the admin page in RStudio Server Pro. I don't know how many of you have access to the Pro versions of these things. So this shows, you can sort of see here, it's the active sessions, and it's clearly a sort of a day of the week type pattern. but you can see it's getting to sort of 60 or so concurrent users. That's on one server. Weirdly, the second server has the higher numbers. I think everyone goes, oh, I'll go on the second server because everyone's on the first server. So that's up to 75 or so. So there's some of these are the same users. So on the Pro version of RStudio, you can open multiple sessions in the browser. But so we've got sort of 100, 120 or more individual R sessions running at any point in time. Which, it's pretty good on 2 servers. So server-based installation offers a number of improvements. So dramatic improvement over desktop in terms of the available resources. I mean, even if you had a desktop computer with 16 or 32 gig of RAM, there's far more resource available if you go down the server road. Shared package libraries. It's nice to have all your packages sitting in a single shared site library that everyone can access. We can enforce a common R version since it's only 1 or 2 binaries running off 1 or 2 servers. And so consistent experience across users is pretty useful in a biggish organisation. And so I just thought, it's worth lingering on this point a little longer. My personal hunch is that the most important reason R has experienced such sort of dramatic uptake and acceptance in the last couple of years is the fact that we decided to go down the server road. I think if we had remained on desktops with that are pretty resource poor, I just don't think it would have worked out. It's really, so this is something we're battling at the moment. It's not uncommon to log into the server and sort of see a single individual using 20 or 40 gig of RAM. That's not ideal, and I'm not going to say that they're working in the most efficient way, but it's the sort of thing they would try on their own desktop, and then if it didn't work, they'd give up. The classic cannot allocate vector of size type error that you will have all seen, I'm sure, at some point. So I think that's the most fundamental thing, and I think government departments and large organisations, that's probably the model they need to look into. And the other thing I didn't say about security, so the RStudio server has its integration with all our other, so it's got AD integration, so you can use a Windows account and all the security follows it, and trusted authentication on SQL Server and all those sorts of things that you may not think about if you're not in an enterprise. And so the Pro version makes that a bit easier. Right, so that's the main thing. But so now I was just going to talk about a few things that have been probably already talked about in other talks. But I think without doubt, SHINee is probably the next most interesting thing in terms of gaining acceptance. We had a sort of thing where we're pretty keen on making web applications, I suppose, at Stats New Zealand. We don't have a lot of in-house expertise, and it's the sort of thing we would probably just outsource if we really wanted to build something. We would probably just hire a contractor to do it. But SHINee is pretty easy. So if you already know R, so you've written a package, it's a pretty, I won't say trivial, but it's pretty simple to then wrap an interface on top and deploy that as an application, including to non-R users. And so it's just been useful in demonstrating that we can do things internally. So even if SHINee isn't the right tool for a particular deployment of a web app, it's certainly good enough for a proof of concept and to sort of show that we can do these sorts of things internally without outsourcing. So that's been useful. So we've used, and the analysts love it, right? Like they make a SHINee application and deploy it to a few people, and they get a bit of a kick out of it, I think. And we've definitely had people who've used R specifically because they've seen other people's SHINee applications and they want to make a SHINee application, and they've learnt R specifically to do that. So that's helped. We currently deploy SHINee apps in 3 ways. So just in RStudio as projects. There's been a lot of talk, by the way, about markdown. I think the projects in terms of reproducibility are just as important. Encouraging people to work in projects is great. We deploy also, we've got a SHINee server internally. We only use that internally because it's connected to our live databases and things, and we're not really ready to try that externally facing. And we also just deploy on shineapps.io. So if we've got applications where our data can just be sort of bundled with the application, we just deploy that way. And so that's how we sort of deploy things externally at the moment. Yeah, I thought this might happen. I thought I'd iframe at least one application. So our environmental reporting team's pretty active. They've got just a raft of SHINee applications that are on our website. So things like, E. coli levels in rivers and all sorts of things. Yeah, it's probably going to take a while to load. I'll just skip that. I've got some links. Yeah, so so here's a few links that you could click on if I can make these slides available somehow. We talked about parallelization. I kind of mentioned our servers are, the 100 cores, 36 cores, 100 gig of RAM. So I think ours parallelization, its concurrency model's somewhat naive, but it's pretty good for a lot of the things that we do. So I've put in a really simple example. I'll just go quickly. Like, I work in sample design, so one really obvious thing that we want to do is simulations. So you've got like a population frame like census, and you just draw, 10,000 samples repeatedly, and then you look at the distribution of something. And we used to do that in SAS, I guess, and it would sort of take, a couple of days or something sometimes. I won't dwell on this, but so here's just drawing a sampling frame from SQL Server. Just a few little functions to do some samples. But here's a naive simulation. So that's just sort of purely sequential. Just 1,000 random draws, and it takes 16 seconds, just as a sim random sample, and 75 seconds as a clustered sim random sample. Whereas the same thing parallelized, and the point was made. So semantically, the program's the same. You sort of just swap, just the apply with an MCL apply, and that's all you need to do. And so you go from 16, so here I've used 20 cores, so you go from 16 seconds down to 1.5 seconds, and sort of 75 seconds down to 6 seconds. So that's been very useful. We do a lot of this, particularly we do a lot of Markov chain Monte Carlo type stuff, a lot of Bayesian methods that we've wanted to use, but we've not had the computational power to kind of do it. So that's been great. There's a plot, why not? The other thing, how am I doing? The other thing that's quite interesting is just the various ways you can use packages. So I like the idea. So you can package up a statistical, method or something in a package. But I think people don't really appreciate how useful packages can be for other things. So even just packaging a data set. So we're pretty lax data standards. So we have a lot of protocol around sort of published documents and things, but maybe not about data we put on our website, for example. So if you download a CSV file off our website, it might have some trailing metadata on it or something, and it's not, might have metadata buried in the column names, all sorts of things. So it's pretty easy to sort of take one of these files and turn it into an R data frame and stick it in a package. And then you can add value to those packages as well. You can jam in functions and SHINee applications and things. So I'm going through this pretty quickly, sorry. But so here's an example of we've got a file on our website called the sort of census mesh block file. It's a pretty ugly thing. So I sort of tidied it up and put it in a little package. It's just internal. But then I just wrote a couple of little functions, right? So one called map demo and one called distribution demo. And they, so you just run this function once you've installed the package, and you can run sort of apps and things. So that's a nice, I think that's an interesting way to go about distributing data. So, install an R package instead of a download a CSV file. It's, interesting idea, I think. The other one is internally using R packages to provide an abstract interface, right? So, your data might live in a SQL Server database. It's got a pretty complicated schema on the back of it. So you write sort of simple functions. You might write a function called, just get aggregates or something, right, where you specify by variables and it goes away and runs queries and brings it back. And and so then you're working with a common interface. It's well tested, so sort of scope for error kind of goes down. And the people that, you're basically just not asking people to write SQL queries dynamically and things anymore. You're going through a common interface. So I think that's quite an interesting idea. We'd probably do a lot more of that. We've got a few packages on GitHub. Some in Bayesian methods. I won't talk about that too much, but there's a Stats New Zealand GitHub page. And so OpenCPU, with anything, you've got to figure out how to make these tools callable from a production environment. So the method we've chosen in the short term is OpenCPU. I always find it surprising when I come to these sorts of things. I think OpenCPU is great, and I don't see it mentioned a lot, which is surprising. So it basically lets you install you write a package, and then every function that's in that package is then available through a somewhat RESTful interface, just as a web service. So you can use it for remote procedure calls. It's really great, and it's got some basic ability to kind of manage sessions, right? So you can sort of run something, it'll make a little temp session, and then you can access the results of that. So as an example of this, we've been umming and ahhing about an automated confidentiality service for a while. We've not been able to do it because ideally we want to make it available as a web service, and we don't really have free capacity to do that. So we've got lots of R programmers lying around, or a few. So you just make a package that does it, and then you just put that package on OpenCPU, and you've got a web service. So I'll just try and make this the last thing I guess I talk about. So here's an example of a function. It doesn't look very interesting, but that count column has had all sorts of confidentiality rules applied to it, right? It's checked to see whether the counts are large enough at some sort of broken down level. They have to satisfy this mean cell size suppression rule. They've been random rounded to base 3. There's all sorts of things going on here. And it sort of happens recursively, right? So if you've 2 variables, 3 variables, 4 variables, it just works. It's and then, well, this is going to be terrible to see. But basically, the function, you saw the function here was called, generate table. So it's the same function. You just bang it on the end of an endpoint. You use HTTP post and stick the same parameters in, and lo and behold, you get a JSON object. So it's a really easy, cheap way to turn R packages into web services. So that's how we use it in our production platforms currently. I'll just stop there. I was going to talk about markdown and a few other things, but I'm doing terribly for time. So, only markdown.